Good afternoon, good evening, wherever you are. Welcome to episode 46 of Codebase Alpha. This is an unscheduled episode due to the fact I'm currently on annual leave, and so all my schedule's all a bit messed up. So we're running kind of streams when I can. So the current schedule will be unstable, to say the least, for the next week or so. And then week after next week, we'll be back to the normal schedule. So keep an eye on Twitter and on the Discord just to keep track of when I do actually pop up and do extra streams. So let's pop across into the code, and I'll try and explain what I really want to get out of this stream. We're going to do a bit more pure C++ really today. So I'm going to try and leverage some of the skills that I have with C# and see if what we can transfer across to C++ and create some classes. So let's go and have a look at the code. So here we are in the plugin processor of our delay plugin. And in fact, if we just scroll slightly down to our process block method, you can see actually is that we're actually working with a chorus effect currently. And the delays are actually commented out. This is all the code that deals with the delay. And what I think we'll start off by doing is try and create a class which implements the delay. And we'll keep it very simple. So just the delay you see here really. So nothing complicated to start off with, because it's the first class I've written in C++. So I want to keep it as pure as possible, really, as what we did last time. So so that's all the information we need. We need to kind of code this stuff here into a class. And what we're going to do is we're going to use some of the fundamental digital signal processing objects that come with FX objects, which is the code that I've obtained from a book by Will Perkle. It's second edition of designing audio effects with C++. Okay, so this comes with a whole bunch of code which contains some full classes of digital effects, but what we're going to concentrate on is try to not use many of those. We're going to use the building blocks which he's provided and which he constructs his major classes from. We're going to try and do our own classes from that. So what I've done before we started this whole JUCE series was to over here in FX objects, it is a JUCE module which I created, a user module which contains the basic code. So you can see here is the FX objects.h file, and this contains a definition of all the kind of the classes that we're going to be using. So I want to create our own version of that basically, which we'll use to build our own digital audio effects in. And we're going to start off really simple by just replicating what we've done by hand. So this kind of coding here is all very well to get started, but obviously it's not a way you can continue to work with these plugins. You've got to start creating classes. And cheers everybody. This will be my first class, so I want to keep it fairly simple. And we'll see how far we get with creating the chorus class. And I also want to either this stream or next I want to recreate a classic effect that Roland included on their synthesizers. It's called the dimension chorus. So we're going to try and build one of those from the basic building blocks that we've got in FX objects. So let's start off. Let's go over to JUCE and open our project. I think this is the project delay, that's correct. So we're going to need to add a file to this. So let's click on the plus. We're going to add a new header file. We're going to call this Codebase Alpha FX.h. We'll save that. So that's our additional file. Now that should be in the right place, I believe. Let's just make sure. so we can see that. So we're just going to I'm just going to close Visual Studio, and I'm going to save and open in Visual Studio. So we should now see our Codebase Alpha FX file here, and it is here. It's not in the source directory, unfortunately, which is a bit strange. So I'm going to close this again. I'm going to remove that file, and I'm going to just highlight that, and then I'm going to click on Add, and then add a new header file, and then we're going to have Codebase Alpha FX. Okay, let's see if it comes in the right place. I think it does now. So let's save and open in Visual Studio, and that does come under source now. Okay, so we can now minimize that producer. So here we are in the in our file. So it's created a nice header for me. So let's put some up there. We've got the pragma once, so we only include things once, and I think we're going to need to have an include. So if I go to plugin processor here, I think this include should be enough. So this gets all the JUCE headers, so we'll have all full access to all the JUCE modules, including FX objects, which is what we want to use. Okay, so we're going to create a class which is going to represent our delay effect, which is like the echo sound. And we're going to actually we're going to try and follow the conventions that are laid out in the FX object .h file. And if I bring that across inside FX objects, there's a class which is basically interface definition, which is audio signal processor, and we need to implement this, I think. And this basically will allow us to use to have like vectors or whatever, lists of types which all implement the same interface. So this is basically this is going to be a base class that we're going to use. And if we look at this definition, we can see we've got 3 pure virtual methods here, which we're going to need to implement in our derived class. And then we've got a bunch of another 3 here, which we don't need to actually implement if we don't want to. In a set sample rate, enable auxiliary input, and process auxiliary input. But the main ones we need to look at will be process audio frame, process sample, and reset. And we're going to add a few others as well. And we've also got I think that's pretty much it actually. Our can process audio frame, and then process audio frame, which is optional, but we're going to use. I believe we're going to use anyway. That's the plan, I think. So let's move that off screen a second. Okay. So let's define a class. So we'll use the class keyword. What we're going to call it, we'll call it alpha simple delay. And then we're going to derive that from so public, and it was called audio signal processor, that one there. Okay, so we've got our basic class there. So let's look at the public methods that we're going to have on there. First thing we're going to have obviously is a constructor and a destructor. So we'll have alpha simple delay. I don't think we need much on that, and then we need a destructor, which is that alpha simple delay. So there's our constructor and destructor, and then we need some private variables. So we'll deal with the private member methods in a second. So let's just just put the private keyword here, and we're going to have our private members and methods in there. So if we go back over to our definition of the iAudio signal processor interface, we can see we've got a reset, a process audio sample, and a can process audio sample, which we must provide. Okay, so reset takes a sample rate. So let's just define that. So so virtual bool reset, and that took in a double, which was sample rate. I believe that was what it did. Okay, so that's that one. Then we've got can process audio frame, virtual bool can process audio frame. That doesn't take any parameters. Jacko JC, welcome to the stream. Thank you for the follow. Have some electric Alf hype. Thank you very much. Yes, Javid X9, welcome to the stream. Good to see you. Yeah, we're doing a bit of JUCE. So this is my first go at creating a C++ class. So yeah, wish me luck, and do chime in with any advice, because I'm trying to use my C++ skills here to kind of transfer that knowledge across and see how far we can get. Thank you very much, Javid. That's brilliant. Yeah, trying to use that knowledge and see how far we get, really, where we're into brick walls. Okay, so we've got can process audio frame, and then the other one we had to provide was process audio sample, which was virtual double. So virtual double process audio sample, and that took in a double, and it called it XN, I think it was. So XN is pretty standard kind of notation for an input sample. So this is kind of X sub n, really, the nth sample that's coming in. So X sub n, that. So there's our basic methods that we've got to override. Now we're going to need some more, and we're going to need to provide, because we're returning can process audio frame is returning true, means we're going to have to provide process audio frame as well. So process audio frame, okay, that's down here. So I'm going to actually copy that. Just pop it over here. Let me get rid of that. Like that. So what this is doing is taking what it's calling an audio frame, which is basically the left and right channels. You can suffix the declaration with override to let the compiler help you out if you can try and break the rules later. Okay, that's so I can just put override here, like that. Okay, cool. Great, good to know. Okay, so those are the public methods that we're going to have to provide. Also, we need to provide some. So that's okay. So yeah, we're passing an output frame pointer to the output frame here. Okay, and then we're going to have some parameters. So if we go back to our plugin processor and I scroll up to where we set our parameters, which is create parameter layout here, you can see for a delay effect there are basically three parameters. There's the wet dry mix, which is the mixture of unaffected sample to sample that we process through our effect. There's feedback and there's delay. So if I go and find our diagram, let's see if we can find our delay plugin. Here it is. Okay. So this is a block diagram of the delay effect, and I think the best thing we can do is actually open that in Paint, so I can write all over it. Have we got recent? We haven't. Oh, there we are, delay. Okay. We'll fill that remaining space with grey, so it's reasonable to look at. I don't like all this white. I've really got into kind of dark theme recently, and so all this white kind of I find it very, very bright. Okay, so when I talk about the wet and dry signal, here's the signal coming through. So this is the unaffected signal coming through here, but we're tapping some of the signal off here. This is going to be the wet signal. So eventually the wet signal comes back in here, and we add it back into the output. So this is, in terms that we just saw, this is X sub n, and this will be what we call Y sub n. So a sample X of n comes in, it's processed through the effect, and then we get an output sample which has been affected by all these various processes that have gone on within here, and we call that Y sub n. So when we talk about the wet dry mix, what we're talking about is the values A and B basically. So how we're going to define it is that A is going to equal 1 minus B. So basically, if B is 0, either there's no wet signal being fed in, then A will be 1, and so we get the whole of the dry signal and no wet signal whatsoever. And as we start increasing the amount of wet, A will decrease and B will increase. It's always in this kind of ratio. That's the important thing to note there. Feedback is controlled by this gain parameter C here, which is the feedback amount. And you can see what we're doing is we're putting our signal through this delay effect, which is here. We're delaying in a circular buffer, and we're tapping some of it off and feeding it back in at a certain strength. And this is what gives us the different strengths of echoes. So it goes echo, 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 and the number of echoes and the loudness of those echoes is what's controlled by parameter C. So let's so we just need to kind of keep that in mind really. So these parameters, wet, dry, mix, feedback, and delay, are the most important kind of controls that we've got. So we're going to need, that's my, I think I just killed my bot. Let's start my bot up again. Come on, bot. There we go, the bot's alive again. Okay. So going back over here then. Over in Codebase Alpha FX, we're going to need to be able to get and load parameters. So we're going to need to define some kind of structure to keep our parameters in, and we can do that. So let's define a struct called alpha simple delay parameters. Okay. So with these parameters, all we need to do is define the individual parameters we're going to use. So we had we're going to define them as doubles, even though we're going to use floats. So double. So this is going to be. We can just. So when this struct, the difference between a struct and a class, I believe, if I'm correct, the default access modifier for the strut is public, so we should be okay just to create them without the public or private designators here. So we can say these. We got wet. We got double wet dry mix, and we're going to set that to 50-50 basically. So that should be okay for that. We had feedback, double feedback, and what did we default that to over here? So we defaulted that to 0, so we'll do the same. 0.0, and then we had delay, and the delay was a double again, and the delay default over here was 0.5. That's half a second. You see, the minimum is going to be 0 seconds, the maximum 2 seconds. Half a second is going to be our default. So we'll set it there. Now, when we define these delay parameters, we also need to do an operator overload. We need to overload the operator for equals or assignment operator. So I've got a few notes written down here how to do this. So this is I believe we do this like this. So we got a reference to the parameters, and we say operator equals, and that takes I believe a constant audio parameters reference parameters like that. Okay, and then we need to define how that actually works. So basically what we're doing here is we're going to override the assignment operator so that we can say that parameters equal something basically. So what we can say is if this is not equal to so if we're not parameters, so everything if they're not already equal, then we need to change the values. So then we can say that wet dry mix is equal to parameters dot wet dry mix. We can say that feedback is equal to parameters feedback, and we can say that wet dry mix dot DARI, and then we can say that delay is equal to parameters dot delay, and then we can return a pointer. We can dereference this and send it back. Okay, so that should be our alpha simple delay parameters struct. This is going to hold the values that our GUI is going to thank you very much, Javid. So I do need those confirmations. So yeah, I think I understand what we're doing there. Okay, so we're going to need some more public. We're going to need some more public properties, some more public methods. We're also going to need to have a private member called parameters there. Okay, so we're going to need to have a so what should we call it? Get parameters. Let's see, what did I call it in my notes? I think I just called it get parameters. Yeah. So this is going to be audio delay alpha simple delay parameters. That's going to return that. It's going to be get parameters. And that's going to take no values. It's simply going to return parameters. Okay, and then we want a void method which is going to be called set parameters, and that's going to take in what's wrong with that? Finally, some audio programming, says Mark gets. Yes, a little bit of audio programming. Yeah, so it's interesting you say there's not enough videos about it, but I don't know if that was because, as you said, cough cough. I wasn't sure if that was serious or not, but yeah, I started off working on a synthesizer project, which kind of piqued my interest in the audio side, really. So Javid said, would you say that JUCE has been an intuitive framework to play with? It's becoming more intuitive. I'm finding that the GUI side a bit more difficult to grasp than the audio processing side. Oh, coughing here to Javid. So Javid actually inspired me to do the synthesizer project. So I watched his synth series, and he had 4 videos on creating a synth in C++. So I decided to do the same kind of thing in C# using .NET Core 3 and WPF and the NAudio library. And so I've got a nice kind of GUI synthesizer which makes lots of kind of nice sounds, and you can play with a MIDI keyboard. So and it's got lots of twisty knobs and things on it. So it's quite nice to kind of look at and to play with. It's very, very basic, but you can't really kind of substitute C++ really for audio programming, because because with the garbage collection you could never really rely on a .NET language, I don't think, to actually to be kind of any kind of professional professional audio system. So yeah. So we want to take in those, don't we? Okay. And then we can simply say, I think, oops. So that should do the simple part of it, at least. We might, if we have to do any processing of the parameters, we can do them within that block. Marget say C# is not performant enough. Sound cards are data hungry. That's exactly right. So my synthesizer actually works surprisingly well. I did expect it to struggle a lot more than it does. It really is quite reasonable as a kind of a toy project, but it's never going to be suitable for writing plugins in. So that's when I started looking at JUCE, and then I just realised to experiment with JUCE I needed to learn C++, and so I decided to do all that on stream, learn JUCE, C++, and learn about DSP at the same time, and it's proved to be quite challenging. I'm slowly getting there. I don't want to be too cocky, really, because, as I say, now I'm going into new territory with this this idea of creating a class. But I should be able to kind of draw on my knowledge to get us through this. So Let's see how it goes. Okay. Right, what's next on my agenda? Okay. So we've got the basics in place. We need to obviously fill in a lot of this stuff. So we're going to need to hold the sample rate down here, and when we reset the sample rate, we can set our sample rate like that. And we're going to need to use that to create our buffers. So let's go over here and see what we do. We've kind of encoded those user definable parameters which the GUI will let us set. And then over here in prepare to play, we're creating a delay in samples and a delay buffer size. And now I'm using a vector here to create the buffers, but we're not going to use a vector. We're going to use a structure which is part of the FX objects header file, which is called a circular buffer, basically. Okay. So we're going to need two buffers. We're going to need delay in samples, and we're going to need a buffer size. So let's go and put those across here. So delay in samples. And then we had delay buffer size. What else do we have? We got a couple of buffers. Okay. So we now reset. Now we can set these sample rate to 0, that to 0, that to 0. Down there, that one should. Is that going to make that go away? What's it saying? Sample rates uninitialized, always initializing member variable. It's gone away now. Yeah, that's good. Okay. So here we can say delay in samples. So we can go back to our plugin here, and we can say it's the sample rate multiplied by the value of delay. So Javid, I've been coding for long. I've been coding for a long time. Yes, I'll go back quite a long way. So, but in most recent years, I've been programming in C#. So that's kind of why my day job. I'm a development manager at a non-for-profit organisation, and we code in C#, but I've done all kinds of things. But I've never coded in C++. I did a bit of C way back in the day, but yeah, it's taking on a new language is always fun. It's always fraught. I do find it exciting. We did some F# on stream a couple of months back, and that was always very interesting as well. But yes, thank you for the comment about being methodical. I do try to think about how these kind of concepts map back to what I know about, and sometimes they do, and sometimes there's a disconnect. So that's where you need to learn something new. But hopefully, I understand enough about what we're trying to get to here. So that's going to be the sample rate multiplied by parameters.delay. which is in seconds. So let's just annotate this. In seconds. Okay, and these values are between 0 and 1. In fact, feedback, we don't want to get it to 1. We'll approach 1, get something 0.98 is what we want, because if we have a feedback approaching 1 or greater than 1, then we get a feedback loop, and it starts oscillating. The virtual circuit we're creating will start self-oscillating, and it's like when you hold a guitar next to a loudspeaker, electric guitar, loudspeaker. It'll start oscillating in its own right, and sometimes that's what you want. But in our delay effect, it's not what we want. Okay, so we've initialized those. A delay buffer size is going to, so what did we have it over here? That was going to be equal to the maximum delay in seconds, which was 2. So that's sample rate multiplied by 2. So we'll do the same idea here. The delay buffer size is going to be sample rate times 2. Okay. So what else we're going to need? We're going to need a couple of buffers. So over in our plugin processor, we have a left delay buffer and a right delay buffer. We don't need to worry about these values because these are for our chorus effect, our low frequency oscillators, and our step value. But we do need the right head, and I believe we'll need a read head as well. Let's have a look. I think we've got a read head. Yeah. Okay, so we're going to need to have a float, which is going to be our read head, and the read head is going to be a float, not an integer, and that's because we work out. Okay, so with a circular buffer, we know we're going to write in a particular location within the circular buffer, and then we're going to work out how far behind the write head our read head is going to be based upon the delay in samples. And the delay in samples, you can see, is a double, so it's a floating point number. And this is because the delay in samples is worked out by the sample rate multiplied by the delay. And it's fine when the delay is like a nice number like 0.5, because if you've got a sample rate of 44,100, then the delay in sample is going to be 22,050. But if it was 0.51, then you can potentially start getting fractional sample delay in samples. It might be, I don't know, 22,000 and 50.4 or something like that. And so we're going to need to be able to actually read the sample value in between integer numbers. And this is we touched on this last time. This was linear interpolation, and luckily the structure we're going to use, the circular buffer class that we're going to use, actually has linear interpolation built into it. So we'll be able to read, at least estimate, a signal value in between the integer signal positions. So if we want to read the buffer at location 1.5, which is normally impossible because it's either 1 or 2, the linear interpolation will actually enable us to get an approximation for what the signal value was at time value 1.5. But I explained all that last time, and so hopefully it should be reasonably clear. But the write head can be an integer because we're always going to write at a particular location. We can't write in between the cells of an array, basically. But we can, when we read them, we can actually try and guess or interpolate what the value is in between those two different cells. I'm not explaining that very well, but it's easier to show you rather than to try and explain it to you. I could draw a diagram, but I still haven't got my graphics tablet, and my kind of hand drawing skills with the mouse aren't very good. Okay, so reset, that's that. We're going to need to set up all of our so that's going to resize that. We're going to need to have some circular buffers, aren't we? So we should have a type available to us called circular buffer. We're going to call this left delay buffer. We'll have another one. Right delay buffer. Okay, it wants us to create. Can we create them at size of 0? Okay. I'll give it this to a class template. So let's go and have a look at circular buffer. Okay, so you want to say it's a template type. So this is how C++, I believe, deals with generics. So we have this kind of template, and what will happen at compile time, the compiler will actually stamp out an actual class, and so type T is the what we're missing. So we want a circular buffer of floats. So we need to put our type specification in here. So this is going to be float. And I really like this template concept. Seems to be a lot more flexible, in principle at least, than the C# equivalent, because it's the fact it's handled at compile time rather than at runtime. So once again, this is where the kind of speed of C++ kind of wins out. I'm the only person in the world that likes templates. Well, it's because it's new to me, Javier. I think that's the problem. I guess if you worked with it, obviously I haven't tried to create one. I'm just using a template, and using templates must be a lot easier than actually creating your own. But it seems to make chronological sense that you create this kind of this template which the compiler is going to stamp out actual classes for, and it's similar enough to the concept of generics in C# that I don't have to really think too much about it, because I'm not creating the new ones. No doubt, if you want to create your own templates, it probably gets a bit more complicated. So I've got my circular buffers, and in my reset, I should be able to create those buffers. Now, I think we might want to so I'm just thinking about the delay buffer size, whether it needs to be have 1 added to it. I think we're going to just size it 1 greater than that, because when we do linear interpolation, if we're in the penultimate cell and we're trying to interpolate, if we're in the very last cell and we're trying to interpolate, I think we might need the value in the very last cell plus 1. So we'll just leave it at that and hold that thought. So I'm going to have left delay buffer. No, I think there's a create on there, create circular buffer. And we get the option of creating the circular buffer power of 2. So what are these two values? So the first one, create circular buffer. Create a circular buffer based on the target maximum in samples. Do not call for from retail audio thread. Do this prior to any processing. Okay, so fair enough. And this one, power of 2. It's pre-calculated, so I want it to calculate the power of 2. The reason why the power of 2 is important here is because of the way it's going to actually operate as a circular buffer. So if I go back over into my C++ source file here, you can see we're having to handle the circular nature of this buffer. This is just a vector, but we're having to say, well, if our read head drops below 0, then we need to kind of send it to the other end of the buffer, so that it starts reading backwards from there. And the same with the write head. If that is equal to or greater than the buffer size, then we reset it to 0. So this is kind of enforcing the circular nature of the buffer. But with the circular buffer class that we're using, it uses a bitwise AND to determine if you've reached the end of the buffer and you need to wrap, and that means it needs to be a power of 2 in size. So Javid, templates are great until it goes wrong. Then you've opened up the doors to template hell. Okay, so there is a template hell then. It's interesting. So yeah, so I mean, I'm here with the eyes of the innocent, Javid. I don't know what awaits me in the future then. So we're going to create what was it called? Create circular buffer. Create circular buffer, and that's going to be the display buffer size. And on the right side here, right display buffer dot create circular buffer, same size. Buffer size. Okay. Right. That's our reset. I believe that should be all we need to do on that. Okay. So let's go back to our plugin processor file and have a look at the code that's in here. Okay, so what we're saying is for each set of each sample that we're going to process, so we're in a loop here, which is looping through all the samples in the input buffers, and we ignore the LFO stuff. We're down in this commented out code. We make sure we update the delay. We smooth it to get our new value of delay in samples. Okay, so we're going to pass in. We're going to pass into this left and right channel data. Okay, so we can probably, so we want a smooth delay. So that's going to be a double again, smooth. So smooth delay is a way of basically eliminating lots of clicks and whistles that we can get if we start to rapidly change the delay. So if we kind of waggle the delay control backwards and forwards rapidly, you get lots of crackling. And what this will do is kind of smooth that transition from one delay value to another, and you get a kind of a whining sound instead of a click as it kind of whirls its way towards the final value. And we can go through the exact process when we come to actually process this process samples, which we're going to do now. So where's my notes on this part of what we need to do? Okay. Not there, not there. I think it's here. So I had to do plenty of notes on this because it's a mixture of creating a new class in C++, which is a new thing for me, and then working with within the constraints of this interface. So we're having to kind of to conform to this this process audio frame method signature here. So this is for processing stereo. So we need to make sure that the number of channels we've got is actually we've got more than, well, the first thing we do, are the channels been provided? So the input channel and output channels need to be non-zero to begin with. Okay, so if we say that if input channels is 0 or output channels is 0, if that's true, then we need to bail out. So we're going to return false because we haven't got stereo, we've got something else. So we could then have mono being pumped into here. So that would say the output channels would be 1. So if output channels is 1, then we want to use mono processing, and mono processing is going to be provided by the process audio sample. This will process, but the difference between these two methods is that process audio sample works on one sample at a time, whereas process audio frame is going to work on both channels, the two stereo channels at the same time. So what we can say here is that output channels 0, not output channels, output frame 0, as there's only one channel out, it'll be channel 0. That's going to equal to process audio sample input frame 0. And then we can return true. Oops. Okay, so this is mono. Use process audio. Come on. Stereo. Okay, so let's write what processing a simple sample would do. If we're processing one sample, then basically we're using simply one buffer. Okay, and we've got a sample coming in. Here's the sample coming in is xn. So let's go and have a look at what happens over here. Okay. So the first thing we're doing is we're doing these operations here. So up here we're going to say that our smooth delay is going to equal smooth delay, yeah. So this is a scaling factor, 0.005 times the smooth delay minus the target delay value. And the target delay value is going to be parameter parameters dot delay. Okay, so this is what does the smoothing. So what we're saying is that say, for example, if we say that the current value of our delay is 0.5 and we're heading towards 0.6, so this will be 0.5, this will be 0.6, so this will be minus 0.1. We're multiplying that by this quite small number, and then we're subtracting that from the current value, which is what did I say, 0.5. So 0.5 minus 0.1 multiplied by this small factor here means it's going to increment a very small amount. So we're kind of gliding towards the value of our target parameter. So this is what the user's controlling here. It means that every sample we process, it's going to take us a time to actually reach that target value. It's not going to try and go there instantaneously, which it would do if we didn't smooth it. And if we don't smooth it and we get that big jump in delay time, that's when we get the discontinuities in the signal and we get the cracking and the popping sounds. And this is going to be our sample rate. Okay. So we're going to pull some of this stuff out into its own method in a moment, but let's write the code to do to process a single sample. Okay, and then we're going to say we've got something called left channel feedback and right channel feedback. So we need those values over in our members. So float left channel feedback equals 0.0, float right channel feedback 0.0. Okay, get those set up, and then we can then we can grab this piece of code really, and we can write our samples away, so we don't need to worry about the right delay buffer because we're working in mono. So this here, left channel data I, is basically our nth sample, xn, our input sample. We're taking that in and we are going to write in. So what we need to do now is to figure out how you write into a circular buffer. So there should be a write buffer, and the write buffer takes a float input. So that looks like it's going to be simply that. Input sample plus any feedback. So that's that part of it. Then they want to work out the read head. Okay, that's doing the linear interpolation there, so we don't have to worry about that. So let's so the left sample. So we can say that yn yn, which is our output, is going to equal left delay buffer dot read, and we should have a couple of versions of this, one of which is going to take the fractional, that's delaying samples, or the double delaying fractional samples. Okay, so that's delaying samples, which is our float. Okay. So we're going to read from that position. This is doing the linear interpolation. Then we want to update the feedback. So let's grab this. The left channel feedback is going to be our feedback, which is parameters feedback multiplied by yn, or yn times the feedback in fact. And then what do? Then we apply the wet dry ratio. Okay, so basically what we're going to say is this is the unadulterated signal and that's the changed signal. So let's just grab this bit of code and we can say that yn is going to be the input signal, the dry signal xn times the wet dry ratio plus the wet signal times the wet dry ratio. So the wet dry ratio is parameters parameters dot wet dry mix parameters dot wet dry mix. Okay, so what we're doing here, we're saying that we're going to take this value here, 1 minus the wet dry mix is what I showed you across here. This is the value of A. A is 1 minus B, where B is the wet dry mix value. So here, if this was 5, this is 0.5. Then A is going to be, A will be 1 minus 0.5, which is 0.5, of course. So that's the amount of dry signal we want to take, and we're going to mix into that the amount of wet signal, which is this one here. Okay, so that should actually process mono. So what do we need to do differently when we're processing stereo? Well, we need to do all of this basically, don't we? So let's just copy this down for now. So the first things we do here, we set out the smooth delay, that's all fine. So the left delay buffer is we're going to write into there the input buffer, input frame 0, and then we're going to say the right delay buffer is going to be taking the right hand channel, which is input frame with an index of 1, multiply by the right feedback, and then we're going to say that left delayed sample is going to be that. And that's going to be input frame 0 there. We're going to have the equivalent here for the right hand delayed sample. Right delayed sample is going to the right delay buffer. The right delay buffer. We're going to need to update the feedback. And then we've got the right channel feedback is the feedback and the right delayed sample. And then left delayed sample. What we can say here is that output frame 0 is going to equal that. Oops. And output frame 1, which is the right hand stereo channel. Output frame 1 is going to input frame 1. That's the dry signal, and then the right delayed sample. Now, will it build? I haven't got any music playing at the moment. We'll put some music on in a moment, but I want to actually try this out. So we built our class. What's this saying here? Smooth delay is uninitialized. So a smooth delay, we can initialize that to 0. Smooth delay 0. And it's complaining that the that should be okay if we rebuild it. No, it's accepted it now. It's take a little while for it to register that change. Okay. Wait for it to build, and then we'll see what we can do over in our main project. So over here, I think we're going to need to include our header file. This is our plugin processor. This is going to be Codebase Alpha effects. Right. I think we might need to include it over here as well. Like that. Okay, so what we need to do, I think, is we're going to comment out. We're going to comment out all the code in here. Let's comment out all the code that we've got. Okay. So having a header file, so we'll put a comment using alpha simple delay. Then we're going to say that alpha simple delay, we're going to call it delay. Okay, We've got loads of initializations up here which we can possibly ignore. So what we need to now look at is what happens within our prepare to play. So we can comment all this out, I believe, and we can start to work in here. So we can say delay.reset, and we want to pass into there our sample rate, which is sample rate. That should configure our delay, our initial delay. And then we're going to want to update the parameters. So then we want to call date. Update parameters, which we need to write. So void, we need to set this up in our header file. As a private method, we're going to have void update parameters. Okay. Then over here we're going to need to define that. Update parameters. So we've done something quite similar to this before when we did the multi-filter. Nimthora, welcome to the stream. Good to see you. I've not seen you before. Warm welcome to the stream. And do stay and chat. We're building some effects plugins, audio effect plugins, and I'm just so these are in C++ using the JUCE framework, and I'm still learning C++. I'm still learning the JUCE framework, and I'm also learning digital signal processing. So I'm learning everything. So I've just written my first class in C++, which is over here, the alpha simple delay class, and now I'm trying to wire that up into our plugin. So commenting a lot of code out that we had before, which was the working code for the delay and also a chorus effect. Now trying to convert the code across so that we can see if our class works. So here we go. So we're trying to do that now. So let's use auto here. So auto params equals delay dot get parameters. Nimthor, thank you very much for the follow. You have some electric Alf hype. So Alf is our little alien buddy who helps around the code base. Minxie Rose, welcome to the stream. Good to see you. So this is him with his supernormal powers, giving you some hype. So thank you very much for the follow. Very, very kind of you. So we're 220. So we're heading towards our total. Gareth, welcome. Yes, permission granted. You're one of our rocket pilots, so welcome. You feel hyped. Have some. So Gareth and Nimthora have some hyperspatial Alf hype as well. This is my favourite. This is all done in real time using WebGL shaders, all created by a friend of the stream, Fuel Snable. So it's the extra hype for you all. Okay, so we've got our delay parameters. So then we can say that params dot delay is going to equal. So we need to dereference the plugin state, and then we need to get the raw parameter, and that's going to be delay. Params dot feedback. Let's dereference plugin state. Get raw parameters. So Gareth, I don't know if Javid's still in chat, but he's been in chat for a little while, giving me some pointers on my C#, so on my C++ rather. So it's been very helpful. So this is feedback. These values here, delay, feedback, they're all defined all the way up here. So these are the three controls that we're actually concentrated on for this first class that we're building. We're going past it. And then params dot wet dry mix. That's once again dereference the plugin state. And then we call get raw parameter value, and that was, I can't remember what that one's called. Glad you have someone that knows. I'm sure, Gareth, that you know plenty. You know a lot more about C++ than you let on. I've seen your streams. You seem very accomplished, and I've no doubt that Javid is. They call him the master, don't they? But I've no doubt that he's a lot more experienced. But you know very little, Gareth. I'm sure that's not actually true. So now we've read the parameter. We've got the parameter struct back. We've filled in the values, and then we're going to just update it. So delay dot set parameters. Set params. Okay, so that's the initial prepare to play. Set the sample rate and update the parameters, and then down here we need to update parameters again in case they're changed. Each time we read a sample from the buffer, we need to check. Well, is the user actually changing those values as we speak? Okay. Now we're going to need to try and pass these values in, aren't we, on that input frame and output frame. So basically what we're saying is delay dot process audio frame. Okay, so this is where my C++ is going to let me down. Okay, so we've got these two values here. So I want to pass in here, I'm passing in an input frame and I'm getting a frame back. So what do I want to do? Why am I called SNB? Because those are my initials, SNB. So I go by that. So Codebase Alpha is Codebase Alpha is the channel, and I go by the handle of SNB. SNB. It's nothing to do with Essen in Germany. I've been mistaken for being a German. How old are you? Because you seem the oldest person who ever saw streaming. Yeah, I'm quite old. I'm probably the oldest streamer. I don't know. I'm the oldest live coding streamer, perhaps. I think there was older people streaming gaming. Yes, I'm reasonably old. Thank you very much. So Nimthor says everyone knows very little C++ language is too big. It's the same with every language, isn't it? I mean, if you say you know .NET, then that's not true, because you know the bit of .NET you've been exposed to, but .NET's huge. So even though I've been coding .NET for, I don't know, 14 years, whatever it is, I can't say that I'm an expert in .NET I know a fair amount, but not everything. How old am I? I'm quite old, Thomas. Quite old. And I think we'll kind of leave it at that. Mr. Dev1, welcome to the stream. Thank you very much for joining us. Okay, so I need an array, don't I? So what's the best way of doing that? So we can use these two values here. To fill in those, the total number of input and output channels. Then we're going to need something to receive our values into and an array. So float. I don't know how to define these things. Can I define it like that? Probably not. Can I then initialize them with a list initializer? Can I do that? Is that going to be legal for me to do, Javid, do you think, to initialize my array there like that with the curly brace initializers? Because we've got we should have left channel data and right channel data. I'm guessing that might be legal. So that'll be input frame and then output frame. Should be okay. Yep, good, thank you. Okay, so then we can skip all of the code that's commented out and go down here. So let's grab this piece of code here and we'll just comment it out down the bottom. I'll just bring it up to the top. So we're going to set our sample. So we don't need to do any of this change here. All we need to do here is to pop in output frame 0 and output frame 1 because this is our process signal. Okay, does it compile for a start? If it compiles, I'll count it as a win, and then we'll test it. You can use data struct. Okay. So cannot delay open file delay.lib. So this is to do with linking, isn't it? So this is where I'm going to be in trouble. So what's it not found? Has it not found my header file? Try again, see what it says. Closed it too quickly. Reset must return a value. Okay. The reset was returning a boolean, was it? Okay. Try again. Your internet's too slow for 1080p. I'm sorry about that. That's a bit unfortunate. I'm running at 30 frames a second, so I kind of was hoping that that would kind of get around any issues with people's having slow internet. But dear me, wine and C++. Yeah, the wine is necessary. Okay, so I've got a linking problem. Can I open the file delay.lib? So what have I got wrong in terms of my header files? Can I open the file delay.lib? Anyone got any? Is it worth having a glance at the 466 warnings? Yeah, well, I think a lot of the warnings are coming from the libraries I've got. I think it's a lot of crud. We can have a look at them, but I think they're coming from the library that I'm using, which does seem to have an awful lot of warnings in it, which is a bit unfortunate. I'm about process audio sample must return a value. That's well, let's fix the actual problems with the code first. So I didn't return yn there. It could just be that it doesn't build properly, or it can't find the lib file. I've got it set up with CodeRush where it actually breaks compilation on the first error. It's built this time, so that's good. Okay, so now the moment of truth. We've built it. Let's start the debugging session. Let's see what happens. So here's our setup. We've got our delay plugin. So only the first three controls are actually live because we're using these are the wet dry, the feedback and the delay. These bottom three controls are to do with the chorus effect. Jojo, welcome to the stream, and you're from Bavaria. Excellent. Good to have you join the stream. So we're just about to test whether the changes I've made to our previously working delay effect actually still work. Now I've refactored it into a class. So let's open up a file. We'll use lightness within, which is part of the free to use unlicensed relaxed daily music, which we use on the stream. And let's wind the delay back to 0, so there's no delay at all, and let's start playing. So hopefully you can hear the music. Can everyone hear that okay? Let's introduce some delay. Good. Now you can hear some echo now, I think. And that kind of whining sound, that's the smooth, rather than getting clicks and whistles and pops, which Minxie Rose got subjected to last time. And enjoy learning about loops, Minxie Rose. Hope that goes okay. We get this kind of whine now. So now let's get some feedback into it. There's lots of shimmering now. Lots and lots of echo. Let's stop that. And there's the echo from me stopping it. That's emptying the buffer. Okay, so let's put a sine wave generator into this, and we'll unplug that, and we'll plug the sine wave generator in. So let's put the feedback right down, 50-50 feedback again, and I've got my MIDI keyboard here. I'll see if we can play in a sine wave. We need to put the MIDI input in as well. There we go. Okay, so it's I don't know if you can hear that. It's not quite so loud. You can hear the echoes. Very quiet, yeah. So it's an unfortunate thing. I don't know how to kind of boost up the sound on it. Never mind. I think it's easy to pick up with the audio player, I think, isn't it? And what I'll do at some point is actually plug it into Reaper, my digital audio workstation, and we'll be able to generate some louder signals with that. Yes, increase the sound by millions and millions of percent. Yeah, that's a good idea. Okay, so I'll just disconnect this one and reconnect this. Let's try a different piece of music. You can definitely hear the echoes on that. I'll put all the wet signal in there as well, you get a lot more echo. So we've got success. I think that's to work first time is pretty pleasing. So let's stop debugging. Okay. So we got our first class. So what say we actually try to do the chorus effect as well? Yeah, why not? Okay, so let's do the chorus. What I'm going to do the chorus is I'm going to do a bit of cut and paste inheritance. I'm going to cut and paste all this stuff, and we're going to just copy it down. I'm going to chop out some code and we're going to rewrite it. So there we go. There we are. So this is going to be alpha chorus parameters. And we're going to be this is alpha chorus, and copy these down here, and alpha chorus parameters, wasn't it? And that. Okay. So we need some of these things the same, so we'll leave those in place. Let's just see what we've got. So we're creating our buffer. That's pretty much okay. Can process audio frame true? It's correct. What we'll do is we'll chop out that code and we'll chop out this code. We'll start that again. Okay. So, what's different about doing chorus than delay? So they're related. Yes, that's why it's called Relax Daily, Mr. Dev1. So, and that's why I like to. We'll have some Relax Daily while we're doing some coding. So, let's start that off. This is There's 3 tracks from relaxdaily.net, which you can download and use on streams or whatever for free. And then there's a whole bunch. There's well over 100 other tracks between kind of 5 and 10 minutes in length, which are a similar kind of quality, and they're really, really great to code to. And I've also got the music to code by that Carl Franklin does, which is about, I think, 18 or 19 25-minute tracks on that. So I've got hours and hours and hours of music that can play in the background, but that you don't have to concentrate on. And that's kind of the key for me when I'm coding with music in place. And I never used to do this, but I've really got into this kind of idea of coding with music. It's got to be unchallenging, uncomplicated music which doesn't require you to listen to it. It's something which is in the background, and it's got certain qualities. So Samp 0623, welcome to the stream. What am I making? So if you type !project, you'll get some information about what we're doing. So we're working on audio effect plugins using C++, which I'm learning, the JUCE framework, which I'm learning, and using digital signal processing techniques, which I'm also learning. So it's all a big kind of learning exercise that we're going through. Okay. Right. So we've got some low frequency oscillators, LFOs. We've got a step and a step. So we're going to need to have some low frequency oscillators. We've got some new values. We've got some new input values. So delay is not an input value anymore. So we've got the rate. This is how quickly the LFO, the low frequency oscillator, is going to scan through the delay times. And we've got depth, and we've got phase offset, which we haven't implemented yet. So probably going to concentrate on these 2 parameters to begin with. Okay. So we want a rate and a depth. So over in our chorus parameters, we no longer have a delay. We have a rate. And we have depth. Let's go and see what those values are here. So our rate is between 0.1 Hz and 20 Hz with a default of 10 Hz. So the rate is going to be, we can set that to 10.0, and we'll just have a comment there, that's in Hertz. And our depth is going to be between 1 and 0, I suspect. That is between 1 and 0, yeah, and it's going to be 0.5 as our default. So hopefully, Samp, you've picked up the project command. So this is what we're doing. What I'm doing is refactoring the code we've written in the last stream to do a chorus effect now. We've done the delay. Now we're going to do the chorus effect. We're creating a C++ class to encapsulate all the logic that does that, to simplify our plugin code. So we're making reusable components now that we can use in other projects. And we're not going to get it tonight by the look of it, though the time's going. But I also want to start building some, replicating some classic effects from synthesizers of the past. So synthesizers by Korg and Roland. We can get the block diagrams of their effects, and then we can use those block diagrams to actually use our building blocks that we've created to put together a recreation of those effects, and then we can experiment with them, see what they sound like, because these are very basic effects we're creating. The delay effect is the most basic delay effect. This is the most basic stereo chorus effect that you can have, and then you can layer lots and lots of complexity on top of it. So what we'll have here is going to be rates, and then depth equals parameters. Depth. So that's the chorus parameters struct. So this is frequency of the LFOs in hertz. So we're going to want some we're going to take care of these problems here in a bit. So we're going to need some LFOs, and luckily, just like we got circular buffers, we actually have LFOs in our little FX objects package. So this is going to be our left LFO, right LFO. So once again, a LFO is a low frequency oscillator. It's an oscillator which is going to oscillate between 0.1 and 20 Hertz. So it's inaudible to the human ear. So it's not the idea is not to be heard, but it's going to modulate the depth. So last time we had the depth control was with a knob that we changed. We're going to have our LFOs modulate that, change that, and for us, and that's going to create the chorus effect. So Mr. OneDev, sorry, searching for keyboard input library better than conio.h. So the person to help you with that would be Javid, if you're still in the chat. What was your main job in life? What is my main job? I'm a development manager, Nimthora, so I have a team of 7 developers I look after. So there you go. There's an answer for you, Mr. OneDev from Javid. Okay, so we've got some LFOs in place. So up here, we can get rid of that. So we've got our sample rate, we've got our delay buffer size, and we've created our delay buffers right and left. Okay, so what else do we do over in our plugin processor? So we actually set up so this is working out the frequency of our LFOs, but I believe we can set our LFO frequencies. We don't necessarily need to do all that, and sine is an expensive mathematical function to call, and we're really trying to be kind of as efficient as possible, and I do believe that our LFOs don't actually call the sine function, they approximate sine, so they're a lot quicker than calling sine. So let's have a think about what we can do. So left LFO, that's got a reset on it. So what do we pass in? We pass a sample rate in there. So we need to do that, and right LFO, sample rate. Okay. Let's go back over here. We multiply by the depth, and then we get the chorus effect here. So we should be good to so rate is in hertz. Okay, so we're going to we're going to process mono first. So let's set up the LFO. So left LFO dot so we need to get the parameters of the LFO. This is going to be, and we'll auto that, left LFO params. That. So left LFO params dot, what we got? We got frequency in hertz. That's going to be equal to our rate. Parameters dot rate. We're going to set the type of. We do this up here. Get the parameters there. So we can set the waveform. So we're going to say that left LFO params dot waveform is equal to, oh, so what does it take? We have to go and have a look at LFO, aren't we, I think? Let's go and have a look at the definition of LFO. Oscillator parameters, params.waveform, generate a waveform triangle or sine. We'll give it to K sine, is there? K sine, yeah. I will take that. Make a sine wave. We'll do the same for the right hand LFO. And we're going to then we're going to say left LFO set params that, and right LFO dot set params right LFO params. Okay, so that's set them to sine waves. We could experiment with that and change them around. Margette's convolution reverb is very interesting, but computational heavy filter, yeah. So it can replicate different acoustic spaces very nicely. Convolution is something I'm interested in trying out, but we need to have some waveforms. So we need to have some samples, don't we? So you need to kind of go into a, I don't know, an auditorium and fire a starting gun and record that very accurately, and then use that that waveform for the convolution. So yeah, there's code that we've got within our library here to help us do that kind of stuff. But so I've not got that far in my book. I haven't got far. So I've got this weighty tome all about DSP theory and creating these kind of these effects. And convolution is kind of further in the chapters, so I haven't got quite read up on that. So we might give it a go at some point, but we might have to take samples off the internet of different, maybe if they're available, some waveforms off the internet to represent different spaces, and then we can see if we can make things sound different using convolution. But yeah, quite an advanced technique, I think. Certainly not something I'm going to look at very shortly. Still kind of struggling with the C++ side of things at the moment. So I'm hoping this is going to be a bit of a breakthrough for me, if we can get these things, these kind of classes working. Because once I've got these classes kind of down in my mind, how you do them, and we've got the kind of some basic kind of templates for creating them, then I want to generate some classic audio effects. So the first one I want to do is the Roland Dimensions chorus unit, and then we might have multi-tap delays and lots of kind of more exotic kind of versions of these very basic effects, and we can kind of compare them, see if they actually do sound any different. They should do, but we'll see. So we set up the waveforms as being sine waves there. I think we can go down here. We're only working on the left-hand channel here, so we only need the left-hand one. So then left LFO dot set parameters. I think it might default that as parameters back, mightn't it? So we better set that waveform again. Like that, and then left LFO params like that. Okay. So then we want to get some output from the LFO. Auto modulation equal to, well, that's been waiting to happen for a while on stream for my pop filter to move like that. So left LFO, what have we got on that? LFO. We got render audio output. What does that take? Nothing. Renders a new audio output structure. So what have I got over here? Signal gen data. Okay. Then modulation dot normal output. So that should give me a sample. So LFO output. Value. That should be a float, I should imagine. Double. And I want to multiply that by parameters dot depth. So this is going to control how far, so we're going to be oscillating about a midpoint. So we're going to say the midpoint is say here, and we're going to oscillate backwards and forwards, and the rate is how often we're going to do that, and the depth is going to be how far we swing backwards and forwards. Thank you very much for that that follow, Margette. So have some Electric Alf hype. Convolution, so Margette, she said, oh, nice, well, I'm going to keep an eye on you then. There's so many audio feedback clips in FL Studio's demo version folders. That'd be really good if we could find some of those kind of things, and maybe we can do some convolution. I really want to get to that level, be able to do that kind of stuff, because I want to understand it. I want to understand how it works. So yeah, convolution is probably maybe we'll make that the ultimate goal, that we get a convolution plugin. Okay, so we got our LFO value. So now we need to use our JMap. Flushy RL, thank you very much for the follow. You have some hype as well. Have some Electric Alf. This is a WebGL shader. This is all being done in real time. It's not a video or recording or anything like that. That's a real time effect in WebGL shaders. So thank you very much for the follow. We really are kind of power 222 double Nelson in cricketing terms. That's great. Okay, so back over here. So we've got to this step. We're multiplying our LFO by the depth, and then we want, for the chorus effect, we want this mapped value. So we're going to these are the magic numbers for chorus. Let's bring this across. So this is LFO left LFO value. So let's make sure we are being consistent. Left LFO value, left LFO output. This one goes in here. So what this JMap is doing, so that's because it is a double. So we need to do a static cast to float that lot, don't we? Because we want to float. Okay. So what this is doing, it says take the value of left LFO value and map it. So the range -1 to +1 is going to map to 0.005 seconds and 0.03 seconds, so 5 milliseconds to 30 milliseconds, and these are the magic numbers for the chorus effect. Delay values. So you get the chorus effect when you have this range of delay. So it's going to oscillate now somewhere in this range, depending upon the depth. So if the depth was 1, it would oscillate between 5 milliseconds and 30 milliseconds. And obviously, as you reduce your depth control, it's going to oscillate about the midpoint to a lesser or greater extent. Okay, so that's our left LFO maps, and then down here we are getting the delay in samples. So we want the left delay in samples, right delay in samples. Okay, so we need to have that. So we want left delay in samples and right delay in samples. Set them to 0 initially. Okay, and we're going to need a left read head and a right read head. We've got these different read heads because in the next iteration of the effect, we're going to add what's called a phase offset, so that the left and right channels can will operate in out of phase of each other, or possibly out of phase of each other. But at the moment, left and right read heads are going to be the same. But so we're going to introduce that complexity at a later time. Okay, so we've got our delay in samples. So we need this value here. Bring that across. So currently we're still doing mono processing. Left delay in samples, and this is going to be our sample rates times the left LFO maps. Okay, and then what do? We calculate the read heads for the left and right channels. Okay, do that. So the left read head is going to be equal to that. Now we don't need to worry about this making our buffer circular, because our buffer's going to our circular buffer is going to take care of that for us. Then we're going to read to write the sample. So this is going to be the input sample, which is xn. Write that into our, add the left channel feedback and write that into our buffer. Okay. So we're converting across from the raw code that we did when we did all this by hand to using the building block classes which are in our library. So which is why I'm kind of reading this code then converting it across. So then we get in our left delayed sample. So float left delayed sample. So that should be the same as we were doing up here, basically. Which is going to be this piece of code here. Except it's going to be left delayed samples. And basically we're into doing the same kind of code as we had here. So we're going to do our feedback. And then we're going to work out our wet and dry mix. And return that value. No, that's not quite right. So yn was equal to what? Yn equal to that. Don't like that. Let's change that back. Left delayed sample with a safe float. Yn is equal to that and return it. It should be okay. Let's go. Make sure we haven't missed anything. This is doing linear interpolation, but our circular buffer does linear interpolation for us, so we haven't got to worry about that kind of stuff. Okay, so that's the chorus effect. That's all we need to do in terms of mono processing. So we're going to be really inefficient. We're not going to do the ultimate refactoring yet. We're just going to get it working. So let's copy all of this for now. Put it into our stereo processing. And we'll do all this for the right hand LFO. So just copy all these over to the right. 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 And right here. And then we want to get our right hand LFO values. So change those over. So that's the normal outputs times the depth, and then we're going to get the left LFO and the right LFO. So we'll map those across. Right LFO, left delayed samples, that's right delayed samples. Update our left and right read heads. Now, as I said before, they're going to be the same initially, but that's fine. We have separate ones so we can do clever things later on with phase. This is going to be input frame 0, and we're going to write in to the right delay buffer. The right hand sample multiplied by any feedback that we're feeding back into it, and then do the same here. So lots of repeated code, so we're going to do some nice refactoring on this, I think, but not tonight. Right. So that's updating our feedback. So our delayed sample is here. So now we can have a look back to our previous class. We can just copy these. It's exactly the same piece of code, got to go here. So our output frame is going to be our output frame on the left hand channel, the input frame times the wet dry parameter there, and the left delayed sample, which is our chorus sample there. We don't need a smooth delay anymore because we're using a sine wave, which is inherently smooth. Let's see if it builds. Okay, it does. Okay, that's not the end of it though. So we need to go up here. Okay. So over in our plugin processor, we're going to need to have so it's interesting that all of this code here, all of this stuff here, is no longer actually required, I don't think. But they're using alpha. So using code base alpha effect classes. So we want our alpha chorus. We'll call that chorus. Okay, and then over in the BPP file we can look at prepare to play, and all we need to do in this one is chorus dot reset sample rate. Okay, in update parameters we can say chorus params is equal to chorus dot get parameters, and then we can say chorus params dot wet dry mix is going to be equal to, and I'm going to dereference once again the plugin state, which is one of these weird kind of data structures we've got, which is an audio processor value tree state or value state tree, one of the two. But it basically contains all of our parameters from the GUI, which we've kind of hooked up to the sliders in the front end. So then we get the parameter value of wet dry mix. And then we can just carry on with that. Then we got our feedback. It's very similar. Get the plugin state, get the raw parameter value of feedback. Once again, dot depth. The rate, so we'll do rate next. That's going to be the same basic structure. Plugin state. Raw parameter, and that's going to be rate, and then depth. So we're going to want to have a drop down box on our GUI, then select whether we're going to do a delay effect or a chorus effect, but we'll just comment out code for now, because we know that our delay is working. And this was depth. Okay. So that's that bit. And in process block, we update parameters, and then we set up our channels. And the only difference here is we're now going to, rather than doing delay, we're going to just call chorus. That one out, and we're going to call chorus. And all this commented out code vanishes because we encapsulated all that logic and all those variables in our classes, so it feels much more like a proper piece of code rather than just kind of regurgitating lots of stuff or splurging lots of code into one method in the plugin processor class, which is not the thing to do. We want everything to be reusable. So let's see if we build and see what happens. What I'll do is I'll stop the music. If it builds, I'll stop the music and then we'll do a debug session. Stop this music, and then we'll run our special debug. Okay, so here's our delay. So this is the delay knob. That no longer works because we haven't wired that up. This is phase offset. We haven't even looked at phase offset yet. So these are the four knobs that we need to actually be worried about. So the wet dry ratio, the feedback, the depth, and the rate. Currently 10 Hertz. Okay, so that's this is a pretty crude GUI as well, so we need to smarten that up, but that's not the object of the exercise at the moment. So let's open our likeness within, our Relax Daily track, and play that. Wow, we certainly got some interesting effects there. So let's take the Is that loud enough for everyone? Can you hear it? So I'll try turning up a bit. Is that chorus effect? Sounds very odd to me. So I'm going to get a sine wave in here to see what that does. This is a bit quiet, so I'll try and turn up the delays there. Yes, it's difficult to tell whether that's actually a chorus effect or not. So I think if we put a sine wave in, we might get a better chance of determining whether it is or not. So let me play a note. It's really quiet, isn't it? So I'll try turning my audio. So it was at 40. I'll turn it right up. Don't know if you can hear it. Let's turn this right up as well then. Still extremely quiet. I think it might well be chorus. Let's see if we can play with some of these controls. That actually having any effect? I don't think that's having any effect. Okay, so let's go and look at our code. I'm not convinced that that had any effect. So let's stop debugging and have a look. Okay, so over in here, are we doing an update params? Okay, over on our delay, we seem to be looking okay. Process audio frame. We set it, each time we process an audio frame, we are resetting our parameters. Are we setting? I bet we're not resetting our so resetting the frequency, okay. Over here, we update params, update parameters. So every frame that we process, we should be changing those values. We didn't set parameters. That's the problem. So chorus dot set parameters, and then we need to pass chorus parameters into that. I didn't think we were having any effect, so let's try that. Let's build that again. Delay there. It does sound like a bit like a weird, a weird tractor beam from Star Trek, I must admit. Yeah. The build's okay. Let's run up that debug again. So let's choose another track, and we'll choose Light This In again. It seems to be a good one to practice with. That's definitely chorusing. It's not a very subtle effect, it's quite... Yeah, it's quite coarse, but that's it. This is probably the most basic chorus we could ever have. There's some quite nice chorus going on there. And then we're getting some of those synthesizer chirps, which are quite fun. Yeah, I like that. Yeah, I think it is too high. It's quite interesting effect. Perhaps not the classic chorus, is it really? Boing or not? Yes, it's going boing, 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 isn't it? Yeah. I think you're right about the amplitude of it. I need to lower the depth needs to be quite small, doesn't it? Yeah. I think it's the depth control that's got too much range. It's a bit tinny. The music's a bit tinny as well. So we try a different track. I think they're all a bit the same though. Particles of Life. To try that one. Definitely the effect there is not on the original track, so that's actually coming from our plugin. So I think if you go mad on these controls, it gets really strange. Lots of really kind of weird detuning going on there. But if you're conservative with the controls, yeah, I think there's something wrong with my parameters. I think you're right, Javid. There's definitely chorusing going on. Oh, that's pretty good. I'm quite happy to get at that point, because the object of the exercise really was to be able to do this. So what we've done is got rid of all that code. We've got rid of all of this code here as well, because it's all been encapsulated into some C# classes. The first two classes, in fact the first two classes and first two structs as I've written in the language, so I'm pretty chuffed that actually worked out. So the only other thing I wanted to do was just to set up the save and recall of the settings. So in here, we can do something with this as well now, can't we? I don't think we need any of that. Like that. I think we can go to our header file and say, you know what, we don't need any of that either. Deleting code is fun. So I think we need to have a revisit the algorithm for chorus to make sure that these figures may be off. So I need to look at the algorithms and make sure they're correct. And we might want to use a triangle wave rather than a sine wave. Maybe a triangle wave would be a bit smoother rather than having that the kind of sine, the curves at the bottom of the sine, you know, the turning points of the sine wave might be making it sound a bit strange. fact, let's try that with triangle and just see if that has any noticeable effect. This is the advantage of using these built-in objects, is that I can just experiment now with different waveforms. Magic Zub is the guy to know. He's a bit of audio nut. Well, if we could kind of get some advice from him, that'd be brilliant. See, I'm learning all of this. This is all like book learning I'm doing, and also now able to actually play around with the sounds and the code to investigate what these various effects actually are like. Which is the great advantage of being a developer, really, that we can actually now code up these effects, and now I'm free now to change parameters, add new blocks into the block diagrams, and just play to my heart's content with different effects. So let's. I don't think I've got a file. I need to settle these down a bit. I think a trial go around is a little bit better. Yeah, it's a fun phase, the playing. Once you've got the code written and you can start playing, we can add other controls, we can put other stuff in. So I want to build this Roland dimension chorus effect because it's got a few more components in it. It's got some high pass filters and it's got some phase shifting in there. To see what that sounds like and then play with it. I think it sounds better with triangle wave. More shimmery. Yeah, that's better. That's a lot better. I think with this sine wave, the changes around the peak and the trough of the sine wave are making it sound a bit odd. That's more shimmery, which is what I expected. Still some detuning going, we expect that. That sounds pretty good to me. I'm pleased with that. So we've got we deleted a load of code, and we've got some classes which I can now play with, which is fantastic. So okay, yes, what I was going to do, I was going to look at over in the plugin processor, we had the opportunity in here to actually save and recall the values of all of our parameters. So it's in here somewhere. Get state information. Here we are. Okay, this is where we get to use a bit of JUCE. So what we need, we're going to save it. We're going to use XML to save it because that's what JUCE seems to want us to use. So we create a unique pointer. Let's type XML element. And we call that XML. That's going to be make unique XML elements. And we give it a name. Probably delay alpha. Alpha delay. Okay, then we can say set attribute, and then we're going to have wet dry mix, and that's going to be plugin state get parameter value, and then wet dry mix. So I'm just going to copy that line and hope not to make any mistakes. So then we've got feedback. We've got delay. I'm just going to save all of the values. Then we've got rate. Depth. And then we've got phase offset, which we haven't used yet. I think it's called phase offset. Yeah. And once we set that, basically it's a single XML element with lots of attributes on it. Then we can use a built-in function called copy XML to binary. Copy XML to binary, and then we pass in the XML, and up here we have the destination data. And we can pop that in there. So that will do that for us. And then to set the state, then it's very similar. Let me grab this. Try sawtooth, Javid. Yeah, that'd be interesting, wouldn't it? We can play with all those things. That's the great thing about it, isn't it? So we'll try. We can try those. What do I need to pass into here? So I need get XML from binary. And that's going to be it's called data, and size in bytes. And then we can basically go and set our parameter values. So I wonder how we update the parameter. Right. This is what I'm not sure how to do. So let's go. Copy state do. Turns a copy of the state value tree. Don't want to do that. Get parameter processor. Remove parameter listener. Replace state. I think that's it. Places the state value tree. Interesting. So JUCE update audio parameter. storing and retrieving parameters. So it's you got to go now, Javid. So thank you very much for being on the stream. It's been a real pleasure to have you here. So thank you very much. And thanks for your help, because it's really great to have someone who knows their stuff to help me out when I run into problems. So thanks very much, and have a great evening. Maybe we'll see you again. And thanks for the kind words about the stream. That's very kind of you. Okay, this is what this is here. Set static version to the opposite. It should read the data. Don't use this method for adding parameters. Using XML. Okay, so there's something useful there. So let's grab that bit of code. Pop that across here. So I'll call the alpha delay. Make sure we've got the right stuff. So this is so XML.get double. Get raw parameter value. So I'm not sure how to interact with this. So we haven't got a direct handle to it. It's all through plugin state. I wonder if that exists. Wet dry param mix. Dry mix param. Doesn't seem to exist. Let's go over to our JUCE documentation and see what it's got to say. Let's have some music back on. So we want audio parameter, audio processor, value tree state. The whole processor. So add parameter listener, get raw parameter values. What we've been using. Turns a pointer to a floating point representation of a parameter which a real-time process can read to find its current value. Get parameter first. So can we say something along the lines of plugin state guessing now, so we might have to go away and do some research on this bit. What have we got here? Arrange audio parameter. So let's have a search. JUCE update audio parameter using audio processor Okay, so they're using replace state. So they're saying you get a pointer from XML. If it's not null, if it has a tag name, replace the state value tree from XML. Parameters. Try that. What they're saying is start plugin state tries to get free from XML presentations designed to cope with random XML data should be fed what was created by using the create XML method. Okay. So that's interesting. So I think that's basically, let's turn this music down. Grief. That was very loud. Sorry if I was deafening with music then, guys. Okay, so this is using copy state. Let's try that then. Rather than this. This is saying plugin state. It's using a scoped pointer, which is a JUCE class. Deprecated uses unique pointer instead. Okay, so that's good. That should be std : unique pointer. Okay, well that's powerful tree structure. That looks okay. So that's, as long as we created this XML representation from a copy state, then looks like that should be fine. And that's nice and neat. That's a good find. So where was that in? That was in parameters best practice 2018. So that's good stuff. Okay, that's good. We'll have to try that at another time though, because I think it's time. What's the time? Nearly 20 past 11. It'll be time to start wrapping up the stream. So let's have a look at what we've got here. Let's just make sure we build, and then I'll push this up to GitHub. We don't build. Cannot convert argument. Why didn't it wait so I could read it? Can convert argument 1 from _ty to constitute string. Reference to a function template instantiation. Make unique. XML element is being piled. That's a value tree from XML. So what's wrong with that then? Cannot convert argument 1. What does it want? It wants a name, doesn't it? It wants a name in there, doesn't it? Alpha delay. Is that what it wants? Too many arguments in function call. So it's where it's getting tag name from, isn't it? So can it convert argument 1 a constant string? Use XML elements. So is it this part here? Let's go and look at XML element. Like wants a tag name. Okay. Alpha delay. This has got to be equals std : make unique XML elements. That Dragon Eye, thank you for the follow. Have some electric elf hype. If you got any idea how to help me with this, that'd be great. So what's this actually returning? So how do I give it a tag name? XML tag, set tag name, alpha delay, perhaps that. I've no idea what XML it's going to create at that point. Try building that. Dragon, you're not too familiar with JUCE and XML, you're afraid. Yeah, well, I think it's causing me a bit of grief. This. I think this is the problem where they've moved to using this the audio processor value tree state, and I don't think it's very clear exactly how you interact with it. That's still complaining about something, isn't it? If I don't do that, build, what happens? Can it convert argument 1 to constant string? Okay, well, looks like we're going to have to leave. I was hoping to leave on a high, but load audio processor value tree state the XML. Unfortunately, it's like very old. Something more up to date. Let's go to the forum. JUCE forum. And const the parameter. Was that? That parameter there, I don't think it's that. It's a pain, isn't it? Really is a pain. JUCE forum. We want state information. Search for that. And then it was audio processor value tree state. If I spelt that right, it'd be better, wouldn't it? Is it value tree state? I think it is. May 2000. Okay, here we go. This is this year. Nothing there. Get state. So they've set it like that, just as we have, just like the tutorial. Okay, so then they've got. Let's just copy. Let's copy the code directly out to there. So it's like the tutorial. So let's just copy that into there, parameters, and this is going to be plugin state. And then this code, pardon me, plugin state. Plugin state. Will it compile this time? It does. So I must have copied something incorrectly. And I want to put some braces around this, so I don't like this if statements without braces around them properly. So let's put those in. Make sure it still builds, and then we can end on a high. There you go, yeah. It's amazing. But it's a good job we've got these forums around to help, because some of this stuff is not easy to figure out by yourself. Without example code, it's and there's a tutorial apparently, but I didn't spot the tutorial. Okay, so we've got that building now. So we've had a very successful evening actually. We've refactored our plugin. We haven't got quite as far as I hoped. I was hoping to start work on looking at creating a recreation of the Roland dimensions chorus effect, but that's good for next time because that's a fairly meaty kind of thing to do. We can also get the flanger effect working on this. So we've gone down from quite a bit of junk code in this class in the process block just to a very nice, neat few lines. Currently we're commenting out which effect we're using, so the delay or the chorus, and we've moved all of our custom code off into these classes. This is my first two classes I've ever written in C++, so I'm quite pleased. So there's a bit of repetition in here, so probably need to apply the dry principle in here, but at the moment I'm not too worried about that. I'm sure we can refactor a lot of this out, especially when you get left and right. Same things happen to left and right channels, we can sort that out. But what I'm going to do now, I'm going to go to the Git flow, and I'm going to end this feature, finish the feature. Okay, so this is our chorus effect. And then we can go to changes. We're going to check this in. We'll call this refactored delay and into their own classes, and added save recall of plugin state. Okay, we'll commit that, and we'll sync that up to GitHub. So let's we'll just need to push that up, don't we? Yep. So that will be on GitHub for you to have a look at if you wish to play with it. It's all yours to play with if you wish to. Here's my GitHub repository, so go there, clone it, fork it, submit PRs, whatever you want to do. It's very much a learning project we're on, so we're not on a hang about. Why is no, we haven't closed our Git flow properly, have we? Let's finish the feature properly. I forgot to commit before finishing the feature. Let's make sure we build still. It's because it's 11:30 in the evening here in the UK, and I really shouldn't be still streaming at this time of night. You get quite tired. Doug and I'm glad you enjoyed the stream. You have a good night as well, and I hope you can join us for another stream sometime soon. Currently, I'm on annual leave, so I'm not doing not working to my schedule necessarily. But after the end of next week, we'll be back to the normal schedule. So hopefully you'll be able to join us. So let's go over to changes. We're okay. We should be able to now go over to sync. And we should be able to sync that now. There we go. So take care, have a good evening yourself, and we're going to see if we can find someone who's coding so we can raid them. That's been pushed up to GitHub, it's on my GitHub there. So I've got a YouTube channel. All my videos are archived to YouTube, so if you feel so inclined, wander over to YouTube. You'll see there's 45 previous videos up there. They're not all audio stuff. We started off writing a secure web API using JWT bearer tokens. Then the next project we built a Alexa skill from scratch. Then we investigated GraphQL and incorporated that into our Alexa skill. And after that, what did we do after that? We built a synthesizer in .NET Core 3, WPF, and using NAudio. And then we've moved on to this project where we're looking at JUCE and C++, and I'm learning JUCE, C++, and DSP all live on stream. So I'm struggling through, and you're seeing the pain and also the joy of actually starting to get this stuff right. So it's starting to come well. The first two streams were pretty rough, but we're starting to have success now getting these effects working and building some C++. So do subscribe to my YouTube channel if you feel inclined to do so. It's completely free to do so. I've got a Discord. My Discord is here. Do go across Discord, and that's your invitation to it. And I'm also on Twitter, so please follow me on Twitter for updates on the next streams. And also I'm a bit of a space nut and a SpaceX fanboy, so we also do some kind of tweets, and we also do some kind of rocket based streams sometimes. So one of the things I'm hoping to do towards the end of the year, if I get the Saturn V Lego kit for my birthday, I'm going to build it on stream. It'll probably take a little while, but that's for the future anyway. Okay, so let's go and find someone to raid. So let's go over to Twitch, see if there's anyone out there who's currently streaming. So let's go. Okay, who have we got? We got nobody streaming on a Saturday night. I'm surprised. Okay then, so we can't raid anyone, so that's a bit of a shame. So what we'll do is we'll call it an evening. So thank you everyone for watching, and I will see you again hopefully Monday. If it's not Monday, it will be Tuesday, or it may be Monday and Tuesday. So take care, and I'll see you then. Let's have some hyperspatial hype to see us out. So take care, everybody. There's Infinite Alfs to say goodnight. Bye, Dragon Eye. I love that effect. Take care, everyone.